Hi, welcome back. So now we are going to look at subtopic 3.8 from chapter 3, potential divider. So in this subtopic, we have two learning objectives that we have to understand. The first one is to explain the principle of potential divider and also to use the equation of potential divider given that V1 is equals to R1 over a summation of R multiplied with V. Okay, let us first look at what is potential divider. A potential divider produces an output voltage that is a fraction of the supply voltage. So basically, we are trying to produce a certain amount of the voltage from the total supply voltage. This is done by connecting two resistors in series as shown in figure below. So let's say we have a power supply here. And this power supply has a supply voltage of V. So this is the total supply. Okay. So in this circuit now, we connect the circuit to resistor R1 and R2 in series. So what are we trying to do is we are trying to get a certain output of the voltage from this total voltage. So to get this certain amount of the voltage, we have to have the resistor so that we can get the voltage across a particular resistor. So we can get V1 and V2, which is a fraction from total V. Okay, as we can see, we are going to produce current flowing from the power supply. This current that comes out from the power supply is going to pass through resistor 1, resistor 2 and goes back to the power supply. So the current that passes through resistor 1 and 2 are the same. Okay, so the current across R1 and R2 are the same current. So according to the Ohm's law, the current that flows in the circuit is equals to the total V divided by the R equivalent, where the resistors are connected in series. So we sum them to get the R equivalent. Okay, so we are now going to expand this to show that the R equivalent is the summation of resistor 1 and also resistor 2. Okay, so let's say now we want to find out what is the voltage across the resistor 1 and also voltage across the resistor 2, a fraction of voltage that we can get from a particular resistor is given as V1 is equals to I multiply with R1. According to the Ohm's law, V is equals to IR. So, kalau nak tahu V1, dia kena current yang lalu resistor 1 darab dengan resistor 1. So, V1 here will equals to I here. We have deduced that it is equals to V over R equivalent. So, I'm going to substitute this into the equation here and then multiply with R1. So, next what I do is I simply rearrange. I insert the R inside here and take the V outside. So, what I get here is the voltage across resistor 1 will be resistor 1 divided by the total resistance, which is the summation of R1 and R2, multiply with the total power supply. The same thing will happen if you were to find across resistor 2. So the voltage 2 here is given as current multiplied with resistance 2. So V2 is equals to V over R1 plus R2. This is the current multiply with R2 and then rearrange, we'll get V2 is equals to resistance 2 divided by total resistance, summation of the resistance, multiply with the total supply. So this is the voltage across V1 and this is the voltage across V2. So let's say if you have 3 resistor connected in series, tak ada masalah. You can still find the respective V. Let's say we want to find V across resistor 3. So what will happen? V3 is equals to R3 divided by total resistance R1 plus R2 plus R3, because all these 3 resistance are connected in series, darab dengan V total. So this is the general form where you're going to have V across yang kita nak cari sama dengan R across bahagi dengan R total darab dengan V total. So this is the general equation here. Alright, so next we're going to look at if the resistance here, the resistance R1 and R2 were replaced with a uniform homogeneous wire as shown in this diagram. So dekat tempat R1 dengan R2 tadi, kita ganti dengan homogeneous wire. Okay, according to resistance equation, R equals to resistivity multiplied with the length of the wire divided by the area. We can say that resistance is directly proportional to the length of the wire. Therefore, if the length of the wire is given, this length will also affect the resistance. Therefore, it will also gives us a certain amount of output from the total voltage here. So, boleh dapatkan V1 across L1 ini menggunakan equation yang sama konsep, iaitu V1 will equals to L1 over L total, which is L1 plus L2 multiply with V total. If you want to find for V2 pula across length yang kedua ini, L2 bahagi dengan L total, which is L1 plus L2 multiply with the V total. So this is for potential divider. You are going to take a certain output voltage from the total. So contoh total dia ada 12, kita tak nak guna semua 12, you only want to use a certain amount. So for that you have to connect resistance so that kita akan ada drop across that particular resistance untuk voltage yang kita perlukan.